Okay, welcome everybody to my talk. Let's start with a quote from Johan Cruyff. He says, playing football is very simple. Everybody can play football. But playing simple football is the hardest thing there is. So if we apply this principle or quota to programming, I can say writing code is very simple. Even starters, like everybody can write code, not so hard. But writing simple code, easy to understand code, is not so easy. So it's very hard. So what's the simple code? It's very valuable to write simple code. Simple code is, of course, first of all, it's simple. It's easy to read, understand, and maintain. So you can continue to maintain the same code, change without affecting other places in your code. Simple code or simple code base follows the same principles and coding style everywhere. When you look somewhere, if you see some patterns applied, if you see some naming conventions, you will see it everywhere in your code base. So, and also it's well organized, so you know where to look when you want to find something. And of course, it doesn't contain some duplication, especially of business logic. So that means when you change some business logic, it should be changed everywhere in your system, not duplicated. So, and also, one of the most important things is one use case doesn't affect each other. So when you change something, you don't break something, some other thing in some use cases in your system. And of course, solid principles. If you apply object-oriented programming, solid principles is the key principle set you should apply in your system. Domain-driven design actually is based on object-oriented principles mostly, and all these principles about simple code actually directly important in your DDD-based applications. In this presentation, I will show you some rules, some principles, patterns. When you apply these patterns, principles, and follow these rules, your code will be much simpler, easier to understand, easier to maintain, and it will be simple. I am Halil İbrahim Kalkan. I am coming from Istanbul to here. I started programming very early times with Turbo Pascal when I was at 14. I graduated from computer engineering, and then I worked in several companies as programmer, software architect, team lead in several positions. Then in 2013, I have started an open source project. It's called the ABP framework. It's an application building framework for .NET developers. Anyone heard ABP framework here? Only one? Okay. We should make more marketing, okay. After 2 years of completely open source and free development, I have started to build some premium features on top of this open source framework, and then I established the Volosoft company. In Volosoft, we are still building the ABP framework and some other software development tools for developers. And our framework applies DDD principles, so I clearly, I can say that I'm working on DDD for many years, and not even just applying these principles, I'm trying to create the best practices and teach these best practices to the community to apply DDD in their code bases. I'm still active coder. I'm managing a company of more than 30 people working on this framework, but I still write code you see on my GitHub contributions. I have 2 books written so far. The Mastering ABP framework is completely about the ABP framework usage. And the second one is a free ebook you can download. I will share the link. It's actually very parallel to this talk, so it can be a good reference how to implement DDD in your application code. Okay, let's talk about the agenda of today. I will start by what is DDD, but I will not talk so much theoretical things. I will directly show examples and rules to you. In the second part is the most important part. We will see how to layer a Visual Studio .NET solution, and how to apply rules and some best practices in our application code, and of course, many examples. Anyone using DDD principles or patterns in their code bases here? Okay, good. But you are trying to learn DDD, exploring documentation, maybe some resources, as I understand, because you came here, you are interested in this topic. What is DDD? It's a simple, actually, definition from Eric Evans. It's an approach to software development for complex needs by connecting to the implementation to an evolving model. So your code base is evolving. The main idea is to design it good, then when it evolves, when it becomes much complex, it is still maintainable. DDD focuses on the core domain logic rather than infrastructure, and it's mostly suitable for large code bases and large domains. Not so simple applications, maybe it's an overhead in very simple applications, but for complex domains, modular systems, it's very suitable. Finally, it helps to build a flexible, modular, and maintainable code base. What it promises is that. So it's based on object-oriented principles, as I said. Domain-driven design defines some fundamental layers, 4 layers actually. The main layer is the domain layer. It's the core layer of your system. On top of that, there is an application layer, presentation layer, and there is an infrastructure layer that supports this kind of other layers, actually. Anyone applying layered architecture in their solutions? Like maybe onion architecture also, very similar to DDD patterns and principles. Okay, in DDD, as I said, there are some principles and some patterns. For the patterns, actually, we can split into 2 areas. In the domain layer, we have some entities, aggregates, value objects, repositories, domain services. In the application layer, we have application services, data transfer objects, and so on. Most of these patterns, actually, in some way applied in many solutions I have seen, even it's not completely DDD projects. For example, repository pattern is very common. The problem in many projects is they're applying this kind of patterns, but mixing something each other, like applying domain logic in the application layer, using entities just to store data, not for business, and so on. DDD is different in this point. So if we want to layer a solution in .NET, we may have such a example solution structure. It's a little bit more complicated than the 4-layered approach, but I have split the domain layer into 2 packages, domain shared and domain layers. In the domain package, typically we have some constants, enums, and some shareable types that can be reusable in every layer of the application. And in the domain package, we have entities, domain services, and repository interfaces, not implementations, but interfaces are located in the domain layer. On the application layer is also split in 2 packages. In the first package, we have contracts, like application service interfaces or data transfer objects. This contracts package is candidate to give client applications or client layers to use without depending on the application layer. The application layer or application package itself just contains the implementation for the contracts. And we have infrastructure layer. You can have a single infrastructure package that implements everything like PDF export, database integration, or third-party some kind of service integrations. Or you have 1 package for each major dependency. Like Entity Framework here, I think it's a major dependency, and it can be in a separate package. And of course, we may have presentation layer and test projects. As I said, DDD interests in mostly the application layer and domain layer. Let's see the package dependencies again to understand it well. domain shared package is dependent by the domain layer. Application contracts also depends on the domain shared package because it reuses some enums or consts on this package. And the application layer depends on domain because it uses entities and repository interfaces and also implements contracts. And infrastructure layer or any kind of, for example, entity framework here depends on domain layer. It doesn't depend on application, or application doesn't depend on entity framework or layer. And web layer can depend on the only application contracts. In this way, it cannot access to the domain objects, which should be isolated from the presentation layer. So this can be an almost ideal solution structure, which is ideal and minimal, actually. Real applications would be much complex, but fundamentally, it's enough to start a good layered project with DDD principles. Okay, with this project in mind, when an HTTP request comes from a browser or some type of API call, like we have a presentation layer or API layer that gets this request, typically. It should not directly work with entities. Instead, it should work with the application layer, just send and receive data transfer objects. These application services should then use entities, domain services, or repositories to implement this use case. For each use case, different entities or different services can be executed, so the application services is responsible to orchestrate this business flow. So in each layer, of course, we have some cross-cutting concerns and so on. There are some common principles before I go to the implementation details. First of all, our business logic should be database and ORM independent. Of course, presentation technology independent. It changed every year. And it shouldn't care about mass reporting or some kind of mass querying from database. It should instead focus on the state change. In every business application, we have data and data structure and data in the database, and some rules that controls how this data changes, actually, if you think data-oriented. So how this data changes is completely related to this DDD business layer. So let's start from the implementation details. I will give many rules and examples. It will be a little heavy, but try to concentrate. Okay, first of all, start from an example case, so easy to understand the system. Everybody use GitHub, I think, here. So in GitHub, we can create issues. We can assign this issue to someone. We can set labels. We may have comments and so on. Typical GitHub issue system. So we will take this as a model for our examples to give consistent examples to you. So here we have an issue aggregate. Aggregate, I will come to aggregates, but basically aggregate has a main object and sub-collections or sub-objects acting and working together. Like, for example, here you see issue has own properties and some collection of comments and labels. It has some relations with other entities, like, for example, repository is another aggregate root here, and every issue is connected to a repository, of course, and maybe assigned to a user. We have labels and users. So basically, this is the example that I will give code example based on. This is our domain, basically. Okay. First of all, start from aggregates. Aggregates, aggregate is a cluster of objects tightly coupled to each other and works together. So when you work with aggregates in your code, there are some common principles you should apply to be properly able to implement DDD. An aggregate root should be saved to the database or retrieved from database as a single unit with all sub-collections and with all properties together. Not lazy load, we completely load it to be able to work. An aggregate root is responsible to maintain its self-integrity, consistency. If needed, it should implement business rules directly. It is not an object like data transfer object, just store data from database. It implements business rules. And the aggregate root here is the root object, this aggregate. They are child objects, you can think like that. So the main object or root object is also responsible to manage its sub-collections and sub-entities or value objects. And when you read this entity together, make some changes and save all together, actually you make only one database save operation. So all the changes you have done is automatically transactional. You even don't need to start an explicit database transaction. And finally, I can say that this is not a strict rule, but especially if you are working with NoSQL databases, your aggregate should be serializable because it will be serialized to JSON, for example. But even if you are working with relational databases, you should actually apply this principle to follow the rules better. Okay, there are some rules to apply these principles. If we follow these rules, we have a code base that applied previous principles. First of all, an aggregate root or aggregate should only reference to other aggregates by ID, not have navigation properties or sub-collections of other aggregates. When we are used to work with Entity Framework Core, anyone uses Entity Framework Core here? Another ORM using like Hibernate? And Hibernate is still used? Oh my God. Okay. Very good. When we have started with ASP.NET Boilerplate, we first implemented an Hibernate before even Entity Framework. You know, and Hibernate was very powerful in the times. But now Entity Framework do everything as I see, so it's good. In the ABP framework, we don't support an Hibernate anymore. But it is really a good tool. Okay. So when you use Entity Framework, you are very used to add this kind of navigation properties or navigation collections to other aggregates. But if you implement TDD, this is not a good design. It's not suggested. Only we should have reference to other aggregate root IDs. Otherwise, this cannot be serializable, of course. For example, if you want to serialize issue, it also serializes repository object. It serializes then all the issues in this repository, all the commands, maybe all the users. If we connect everything together, it cannot be serializable. And it cannot be easily usable in a, for example, document-based database. So, second principle, or maybe a little small tip how to design and how to decide things, is you should keep the aggregate root small. Because, as I said, you will always read all the aggregate together and save together. So it should be small. It should not be 1 megabyte, for example. So here you see in the role aggregate, we have collection of users. And in the users, we have collection of rows. Second approach can be true because a user may have a few roles, but a role can be assigned to be maybe millions of users. So whenever we get a role, like for example, moderator role, we don't want to get millions of users from database. So if we implement like that, we cannot apply this principle. So consider object used together to apply business logic. Of course, query performance, we are engineers, and data integrity and validity. When we see some examples, and you will understand why we need objects used together to ensure data integrity. When it comes to primary key, designing primary key, there are, of course, different schools, but I suggest you to use GUID as the primary key always for aggregate roots. But in any way, even if you use integer or another thing, it's not so big problem. But we should define a single identity because aggregates are identified by identity, not by data like value objects. So a single ID is good enough. But if you are designing sub-collections, like, for example, organization user, an example, You may not define an ID for this entity. Instead, a combination of these two properties can be thought as an identifier. So this is an option. Constructor is the most important method actually of every object because it has some very important responsibilities. First of all, it should force you to create a valid object, valid entity in this DDD world. So it should get required arguments, required properties as the argument, but only the required, not all the properties necessary for creating an issue. For example, you don't need to assign to a user. It can be optional or it may not completely be in the constructor arguments. So keep it minimal, but always at required. And of course, check if it is valid. For example, here text is required, so we should check before assigning to the text property. And always initialize collections. This is an important problem in many code bases. I'm creating an issue, then add some label, and I'm getting null reference exception because the collection of labels is not initialized. But if we do it in the constructor, it will be always available and initialized. We can create a private constructor for this realization purpose from getting database, ORMs want. And if you use GUID as an ID, I definitely suggest to get it as a parameter from the constructor instead of using GUID.newGUID because it doesn't create sequential GUIDs and it can become a problem when you especially saving this to a relational database about indexing and, it's not ordered. There are some services that create ordered GUIDs. Okay. As you see, for example, I have taken text and checked it strictly to ensure that it is not null, but it still has public setter. So anyone can set text to null after creating the entity. So we should not also allow this case. So it's best to define some methods or property accessors, arrange them to not allow this kind of invalid state. So here you see we have private setter for text and some private setters for some other properties. Here I have a setText method. It checks if the text is filled, if text is not null. And this is actually more interesting because you see in this example, close reason and is closed property are actually related to each other. When you close an entity, close an issue, you should provide a close reason in this simplified example. So instead of make it public set, if in this case anyone can set is closed to true without providing a close reason, I can add methods like close and reopen like that. So close ensures that it has a reason and reopen also makes the close reason null. So in this way, there is no way to make the entity in an invalid state. So it prevents validity of self-validity, actually. Okay, in addition to simple property checks, we can, of course, throw some exceptions in any case. Throwing exception is something programmers hesitate to do, as I see, instead of they try to use return calls. But exception is not something bad. But in this case, if you want to properly implement DDD, it's best to define some special exception classes. And for example, here, lock has a business, like to be able to lock an issue, it should be closed first, then lock it. And also, in order to open it, it should not be locked. So these business rules, if we implement it in the entity level, there is no way to bypass these rules. But if we apply these principles or apply these rules on the application level, it's possible to directly set these properties on the entity and ignore the rules. So implement as much as rule directly on the entity class to make your entity more consistent and valid always. So another example can be for example, I want to assign an issue to user, but I want to check if the user has already too many issues assigned. Like, for example, there is a rule like cannot assign more than 3 issues to a user in a time. So how to do it? First way can be I can make the assigned user ID with private setter, so anyone wants to assign always should call this method. So in this method, I'm getting a user entity and getting a service. It's a little weird because getting a service in an entity method is not very common. But it ensures that checking this business rule, and it checks and throws an exception, otherwise assigned the user. And also notice that I'm not getting user ID, like a random or arbitrary GUID value. Instead, I'm getting user. So I want to be sure that there is a user entity with this ID, not a random ID here. So this is a way to implement this business rule. But there are some other ways, like creating a domain service. We will come to domain services a little later, but we will continue with the repositories now. After entities, creating entities or updated entities, we need to make some database operation. So repositories is for that purpose. It actually hides data access logic from the other parts of the application. Acts like a collection-like interface with the to the database read and write operations. We should define interfaces of these repositories in the domain layer and implement in the infrastructure or some kind of package like entity framework package. Repositories should not include domain logic. This is a very important rule, and when I see code bases, I see this rule is violated many times. Even you are using storage procedures also? Okay, like writing code in storage procedure, writing your business in your storage procedure is like including domain logic to your repository layer. So we should be care about that. Also, repository interface, interface, should be simple, like get objects, save some objects, but it should be ORM independent. For example, entity framework has DB set property. We cannot return a DB set from repository. In this case, I can directly use entity framework core. Why I'm returning DB set? So this is an example. It should be ORM independent. And one of the most important rules, we will create repositories only for aggregate root objects, not all entities. Because as I said, an aggregate should be retrieved from database as a single unit. We shouldn't directly access child entities of an aggregate root. So this is an example of how we may accidentally leak our business logic into repositories. See, there is a very simple repository, issue repository, and we want to get inactive issues from database. So the question here is, what is inactive issue? Is there a property or another way? Here we have a few properties like is closed, assigned user ID, creation time, and so on. So actually being inactive is a rule related to these objects together. Here, the implementation. You see that I'm getting the DB context for entity framework core and accessing to DB set of issues. And this is the where condition I'm writing. For being inactive, an issue, it should be open first. Then assign it to nobody. If I assign to someone, it is not inactive again anymore. It should be created 30 days ago at least, and it should not have a comment in the last 30 days. I think that in these conditions, an issue can be considered as inactive, and I can make some business code based on that. So this is actually an implicit definition of a business rule accidentally leaked to database query. When we do it in a database query, what if we want to reuse the same logic, for example, in the issue entity? I have an issue class, and there is an is inactive that returns boolean, a method, and I want to apply same business logic here. So what's the solution? Copy-paste? Actually, there is a solution. The specification pattern. Anyone heard specification pattern? It is one of the less known patterns of DDD. Probably everyone knows repositories, but specification is less known. But it's very useful. Specification will allow us to define these conditions in an encapsulated way. It's a name it, reusable, and combinable class to filter objects based on your domain rules. Basically, in original definition, it has a just T of specification interface, and you send the object, and it returns true or false. If it is inactive, it will return true, otherwise it will return false. You can think like that. But if we want to make it more practical, like in this topic, like pragmatic, we can also define another method that converts this specification to an expression. You know, expression we can directly use in LinQ to filter and so on. So this can be a base class to define our specification objects. The implementation is not so important. You can find from internet. You don't need to memorize all. But it basically needs to be weights that derived class implements to expression method. Let's implement for our specification. The name reflects that what is this specification? Inactive issue specification. It derived from the specification of issue, which is the entity type. And you see, it just actually returns an expression. And this expression now is reusable. When you want to get issues from repository, instead of creating get inactive issues method, you can just create a get issues method, which is more generic and more reusable, and gets the specification. So in this way, we extract this specification out of the repository. We didn't include in the repository. So implementation is very simple in this way, because you remember that specification is convertible to expression. So we can directly use on the var method. Even this to expression call is unnecessary actually, but I want to show it. So we can just query from database like that. And when we want to call this method, we just use get issues with new inactive issue specification object. So this new object is a filter. If I want to reuse this in the issue class itself directly, instead of the application, now I can create a method like that, create a new inactive issue specification, and call the is satisfied by this. If this object is satisfied by this specification, then it returns true. So now it is reusable. Of course, specification is not that simple. You may have some kind of parameterized specifications, for example, to check, for example, if an issue is assigned to a milestone, we can have this kind of specification. And now we can also combine specification. For example, I want to find inactive issues in a specific milestone. So this specification can be combined with an, or, and so on. So it's a way to create, name it, and reusable filters in your domain. In this way, when I change this inactive rule, it will directly affect all database queries. It will affect where I use it as a code and so on. So now return to domain services. As I said, domain service can be used to implement some business roles that may depend on external services, especially because entities may not reach external services easily. It cannot utilize dependency injection, while Entity Framework Core in last versions provide a way to dependency inject some services to entities, but this is not very practical actually, and it has some problems. Anyway, when you want to implement some business logic that depends on external services, it's not easy to implement in entities. So domain services is a solution. Also, maybe this business logic is related to multiple different entities, so where to write this code? So it's best to write a domain service that implements this business. So domain services always work with domain objects or primitive types, like integer, GUID, or issue, comment, this kind of entities. But not data transfer objects. Data transfer objects is upper level or application level concept. I will come to this point. So the code was like that, but it is a little ugly because whenever I want to call this method, I also need to dependency inject this service and pass to this method. So it makes a little complicated to use this entity. So instead of this, I can make the assigned user ID private and create an internal method. You know, internal method is can be called from the same package in .NET. So I can call from the issue manager domain service. Here you see, first of all, domain services are registered to dependency injection, so it can inject other services like repositories. It can have an assign method which gets an user and issue. Now it uses some specification to make it interesting. Gets count of issue count from repository, check business rules, and then assign on the entity level. So in this way, I can apply business rule in a domain service and make it reusable everywhere in my domain and application layers. So application service, another way to implement business rules. The difference between domain services and application services may be one of the most important topics on DDD, and I will cover in this talk. But mainly, application service first implement use case of the application, not the core core domain logic. Use case is actually one use case is any kind of interaction from users or from third-party clients to your system is a use case. Like creating an entity, deleting an entity is typical use cases, or make money transfer between two users. Everything, every touch, every request is a use case. As I said, it doesn't implement core domain logic, but it only implements use cases or business logic specific to that use case. It gets and returns data transfer object, never returns entities because our purpose is to hide entities and other domain objects from upper layers. It can use, of course, domain services, entities, repositories, and other domain objects to be able to execute this use case. Let's see an example. This application service implements a use case that assigns an issue to a user. Actually, we have seen already done in the domain layer, but here it's the application layer because the domain layer is not directly usable by the presentation layer. So we have application layer between them. So this application service method gets the request first from presentation layer. It gets a data transfer object. It first, of course, can inject some other services to implement this use case. It gets a data transfer object, simple, just user ID and issue ID. Actually, almost all use cases are very similar. It's similar. It gets some entities from database, performs some business logic, throw out entities or domain services, then saves the changes. This common pattern should be implemented in every use case. So here you see, in order to implement this use case, we have two different objects, two aggregates, one issue and one user. We get from database, and then we use domain service because we don't want to implement or duplicate this core domain logic. And then finally, we know that issue has been updated, and we are saving it. So as a final note, this update operation actually is not necessary for Entity Framework core users because of change tracking system. It will know if this entity has been changed. But I still suggest to use explicit update for a few reasons. You may change entity framework later. You may, you want to be entity framework independent, but this is like implicit dependency. It's not direct API call to entity framework core, but it's actually a dependency. If you change to another provider, it will not work. So your business should be independent of infrastructure, so it should directly update. When it comes to data transfer objects, as I said, the application service gets and returns DTOs. A DTO should be serializable, so it should have a public constructor. It should not contain any logic, of course. It's just for transferring data, that's all. It never inherits from entities and never refers to entities, which is sometimes I see this common mistake because I have, for example, product entity, and I want to create a product DTO. I don't want to copy-paste or rewrite all the properties, so I inherit from the product class. Of course, it's very wrong, because in this way, our business logic and everything leads to the presentation layer. But if I designed my application as I describe it in the layering part, it's not actually possible, because DTOs in the application contracts package and domain services or entities in the domain package, and they have no direct relation. If you implement your layering good, this is not possible even accidentally. So, there are two types, DTOs, input DTOs and output DTOs. There are some principles. If you follow these rules, your code base will be easy to understand and maintainable. If you have too many DTOs everywhere, and actually it's another mess. Okay, when you design a data transfer object, you define only properties you need. This is interesting because you may think, why I define a property that I will not use? But it happens, believe me. It happens because we are trying to reuse same DTO for multiple use cases. In one case, it is needed, but in other case, it is not needed. So when I read the code, I cannot understand when this property is needed or when this is used, and so on. So a typical example can be like that. I have a user application service. I create, update, or change username. There are three use cases in the system. And I reuse user DTO. Because I have user DTO, why I define another one? But it's not true. For example, here, ID is not used on create. It's only used on update. Password, for example, is not used on update or in change username method. Or creation time even should not be here, because creation time should be calculated in the server side, not in the client side. So it's not a good idea to have a single DTO and use it everywhere. It's a very bad idea. Even the application is much better than that. So define only properties needed for this use case and don't reuse same DTO. In this example, you see, I have 3 use case and 3 DTO, which is only needed. When I even look at the DTO, I can understand the business logic, even without looking to the source code in this way. Otherwise, I cannot understand, even if I read the source code and so on. When it comes to validation, of course, all DTO objects should be validated before execution of business logic. Some kind of formal validation is pretty good and suggested. Even when you use ASP.NET Core, these validation attributes are automatically checked by entity as ASP.NET Core and so on. But it doesn't include some domain logic. For example, checking if username was already used or no. It's because too much business logic. It should be simple. It should be in the domain layer, not even in the application layer, because it's a core logic. For example, no two username can be same. It's very core logic. If it is violated, then many things has broken. For output data transfer objects, I can give some personal advices. Maybe you may not like these advices because a little personal, but I can say that it is best, based on my experiences, it's best to keep DTO count minimum for output data transfer objects. And in this case, I say reuse wherever possible. As opposite to input DTOs, it can contain more properties than client or user interface needs. It may just not use it, that's all. And it's a good idea to return an entity DTO from create and update methods as a common principle. Of course, when performance is critical, you may create fine-tuned methods and so on for really critical paths. But in many cases, these are really good enough because maintaining a good code is much more important, actually. When you have performance problems, you can optimize. But when you have really unmaintainable code base, you cannot survive the project. First, design. So in this example, you see we have an application service. We have several get methods, like I want to get user, OK, ID and user detail, no problem. But I want to get roles of a user. I have another method. I have, for example, created a method like just get username and email because I thought that I don't need another property and created such a method. Or I have a create or update method which returns completely different objects, but actually they can be same object. So it's best to use only user DTO. That's all. Even if you change a username, return all the DTO as a return value. So it can even contain roles. So no need to get roles method. You can get and then read roles from here. As I said, if it's very performance critical, you may think about that because it always requires to make join to the rows table. OK. When it comes to object-to-object mapping, it's very common to use object-to-object mappers. Anyone using here like object automapper or another kind of mapper libraries? Automapper becomes paid, do you know? Yeah, it became actually. And in ABP framework, we are switching to Mapperly. Anyone use Mapperly? Yeah, it's also nice. It's a source generator based on object mapping library. Anyway, object mapping is very common because you have entities with 20 properties and a DTO with 15 properties. You don't want to write a code one-to-one mapping. But we should be carefully. For example, some tools has some kind of configuration validation that detects failures or property name changes. If your tool supports this, of course, enable this. As a very important rule, never map input DTOs to entities. But you can map entities to output DTOs. So I can say that use object mapping only for output DTOs. Because, you know, we have a constructor, primary constructor, which is responsible to create valid object. If we blindly map this input DTO to create a new issue object, how we will apply business rules? So we shouldn't blindly and use DTOs coming from user to create entities. After creating the entity with primary constructor, we can, of course, use some additional things. For example, the constructor has no, assigned user ID in this case, for example. I created with minimum required arguments. Then for additional properties or additional business rules, you see I used issue manager to assign user to the issue. Then save it and return the DTO object. So this is a good example how we can create a new object. Create with primary constructor, apply additional rules, save, and return a DTO. OK, domain-driven design, have a separation between application logic and domain logic, which is very critical, as I said. I will also mention again. But it is especially important when you have multiple applications. For example, here we have a back office application, which is used by our employee, which is trusted people. We have another web application, which is server-rendered web application used by end users, like an e-commerce application, and we have a mobile application. In many cases, when you see code bases like that, there are separation of business logic should be implemented for each application type. I mean, a rule in back office application may not be applied in mobile application, for example. They may have some different rules. So it's best to create separate application layer for each application type and reuse a single domain layer which should contain the core domain logic which should be applied everywhere. So as I said, in DDD, business logic is separated into two parts. And I will give some examples to clarify which logic can be domain logic, which can be application logic, and use case specific. Let's start from an application service example. You see, we are injecting a domain service, and for every method, we do nothing and just call the domain service. This is a very bad example, because the application layer has no responsibility, and for every CRUD operation, we are using the domain service. Actually, domain service is not responsible for CRUD operations. It's for applying business. So, as a good principle, don't create just simple CRUD operation in your application services. We can directly use repositories. And of course, there is another problem here. We directly pass the DTO to the domain service, which should not be. Domain services should work with entities. Another example can be a domain service. This domain service just gets a name and tries to create a GitHub organization. You think like that. But we are applying some rules. First rule, we should check if the organization has already existed with the same name. Of course, this is an important domain rule. The second, we are checking authorization, if the user has permission to do that. Authorization is responsibility of domain application layer, not for the domain layer. Okay, we have around 7 minutes. I will be quick. Also, session tracking or accessing to current user is another logic that should be applied on higher levels, not in the domain layer. For example, we may have a background service which also creates organization in some cases. You know, in this case, it will not need permission. It will not need an active user to implement this background service. So if we do that, this domain service will not be reusable in background services, or in another case that doesn't require permission. So then it creates an organization object, inserts to the repository. It's a little bit discussable. It's actually a responsibility of application service, but maybe acceptable in some cases. And finally, sends an email, which is not actually core domain logic, sending an email. It's a side effect, actually. It can be implemented with events or some kind of domain application service. Let's see an application service example. In this case, it also reuses the same domain service to create an organization. First of all, it has a unit of work attribute. It's not so important here, but ABP has a unit of work attribute like that. When you use that, this method body becomes transactional automatically. So after that, it can check authorization, because in this use case, we need authorization. OK. Then it makes some payment charge, then creates the organization using the organization manager, which is domain service, sends some email, and return organization, which is wrong because it's a domain object entity, and we are returning entity from application service, which is not true. So only discussable, there are some discussable things, but maybe not clear to you. But one example can be payment. For example, if you think that when I create an organization, payment is very important, think why we put here maybe not in the domain service to guarantee it's always executed. Actually, it seems like that, maybe, but actually it's not like that. For example, you have a back office application, and I call it your worker with phone, and I couldn't create my organization. complete the payment, but it hasn't been created. Can you create for me? Maybe they can create without any permission requirement. They can create without any payment, and so on. So this is a use case where an organization can be created in different ways. So payment before the organization creation is just specific to this use case. I can recommend some books, of course, like Domain-Driven Design by Eric Evans, of course, the fundamental books, and who almost invented this concept. And this book is also very good for practically implementing DDD, because the first book is very theoretical and hard to understand, actually, but it's suggested. Clean Architecture, of course, it's a very popular book. Probably all of you know Clean Code book. It can be taught a continuation. Anyway, and you can also download this ebook. I wrote this ebook based on this talk, actually. It has many parallel points. So thanks for watching me, and thank you for joining this session. If you have questions, I think we have a few minutes.
Did you make any performance checking on a framework?
ABP framework. Yeah. Sometimes we are.
Huge data sets, for example, in our application, we manipulate with huge data sets. We have some tables like 200, 300 million records. And did you make any?
I can hear. If,
did you make any performance check on this?
Yeah, but I think Enter framework should make check, because we are not building ORM. We just get the request, and with repository pattern, we are transferring to Entity framework core.
But also some layers in your domain architectures, is like authentication, checking permissions, audit logs, blah, blah, blah. It's many other things around that. It is not only entity.
Definitely.
Low level.
Definitely. You are right on that. But it is not very related to row count, for example. Even if you get one row from database, same authorization, same audit logging will work. So for example, if you get one record from database, half of this performance will be maybe ABP. If you get 1 million, probably less than 1% will be ABP related.